Hello everybody. Today we're going to talk about Cisco 300-425 exam review. We're going to take some questions from the same exam as an example and solve them together in order to critically think how to solve wireless issues. But before that, I'm going to talk about 591 Lab. It is the top training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. About the Cisco 300-425 exam review. It talks about designing Cisco Enterprise Wireless Networks, but in this video, we're going to talk more exclusively about site surveys, some of the questions that we might see in this exam about site surveys, wireless location tracking, and how we can track some of the devices in a certain location, in a floor or in a venue. And we're going to talk about high availability between multiple controllers. If we have multiple controllers and we do not want to have a downtime, and we want the access points to have always to be online. And also we're going to talk about RF interference or radio frequency interference, some of the issues that we see in any Wi-Fi deployment. So to start, our first question is, an engineer performs a wireless site survey of a multi-floor building, okay, for 2.4 and 5 gigahertz bands. The customer wants to identify non.11 sources of interference. Which survey measurement must be included in the survey? So here is something that we need to understand about this question, or to divide it. If we're going to talk about non-Wi-Fi, non.11 sources of interference, we're talking about anything that is not a wireless interference, that not is caused by another access point or another Wi-Fi source, such as, for example, a lot of things around us actually cause interference, such as a microwave oven, a TV, a screen, an LED light. A lot of things, like for example in hospitals, a lot of machines work on the same bands as 2.4 or 5 gigahertz that causes interference with our Wi-Fi devices. So these are called non-Wi-Fi sources of interference. So here are the options that we have: co-channel interference, channel utilization, spectrum analysis, and signal to noise ratio, or SNR. So let's take it one by one. Co-channel interference. When we talk about co-channel interference, we have, in any deployment, we have multiple access points that will work on a single channel at a time. For example, here, if we take AP1 and AP2, these both APs are working on the same channel, channel 6 and channel 6. So these two are actually having an interference between them. But this is actually another Wi-Fi interference source. This is not a non.11 Wi-Fi interference, because we're talking about both are a Wi-Fi interference, a wireless .11 interference source that they interfere on each other. But our question again, remember, is to identify a non.11 source of interference. So it cannot be a co-channel interference. Let's talk about channel utilization and also signal to noise ratio. So we're going to talk, when we talk about SNR, it's basically the signal that we receive. It's the power. It's calculated in dBm over time, or over the signal or the noise that we get. So the higher the value of SNR, the higher the signal received. If it's low, it means that we have a higher noise. But again, SNR calculates the Wi-Fi source of interference. It does not show us a non-Wi-Fi interference. So also these two options, the channel utilization and the SNR, is not an option. But what about spectrum analysis? Spectrum analysis this is the only thing here can help us, because if we take a spectrum analysis just like this one, it shows us the channels from 1 all the way to 14 or 13, we can see at channel 1 we have a lot of interference here. Okay, it can be from multiple sources, but it depends on the shape of the interference that we have. It will identify which kind of interference, what kind of device that is causing this interference. For here, in this example here, I can see that there is a lot of interference on channel 1, but there is not much on channel 6 or 11, for example. So I can use both of these channels, but I cannot use one because it's gonna be very bad signal. And when I talk about the shape, for example, one of the shapes that a microwave oven creates when working is like a curve and a kind of a dent in the middle of it. So here we can see like this curve, this one and this one over time, that these are microwave ovens actually, and we can see here a packets or normal traffic. So here is the spectrum analysis actually the only one that can show us a non-Wi-Fi source of interference. So the answer is C, spectrum analysis. Next one. An engineer is deploying a new APs to serve IEEE.11g through .11ac clients. Okay, so we have .11g, which is 2.4 gigahertz radio, all the way through .11ac, which is a 5 gigahertz radio. So keep this in mind. This is very important that we have both 2.4 and 5 gigahertz radio, okay? And we want to use the ECAHOW site survey tool. I'm going to explain it in a bit. What is this tool? To verify the RF coverage. Basically, this tool is that we can take, it helps us to visualize any coverage in any floor or any space. So for example, in this one here, we can see the access points deployed like this one, and the channels that they are in. And we can see that whenever we have a green color, that it's a high signal, and whenever we have a red or a yellow, that it's a little bit bad signal. So it's a tool to visualize the coverage that we have. If it were green, so we can ensure that these offices right here, they're gonna have a good RF signal or RSSI value over this office, for example, which is almost yellow, or this one. So we have to visualize this in tools such as ECAHOW survey tools. Okay, so management wants the engineer to verify and create coverage maps, the one that we just saw, it's called heat map or a coverage map, and they want it as quickly as possible. Which configuration accomplishes this goal? Okay, so if we're going to talk about like we said, keep in mind that we have two radios here. And since we have two radios, definitely I'm going to exclude or eliminate anything with one wireless adapter, because in order to actively do this site survey, we need two wireless adapters in order to listen to 2.4 radio, and also at the same time, so we don't have to do it multiple times, at the same time to also to track 5 gigahertz. So by this, I'm gonna definitely exclude and eliminate any option that says one wireless adapter, because again, we have two adapters, we have two radios that we need. So I'm gonna eliminate by default any answer that says one wireless adapter. So we are left with two options: whether passive mode, whether I want to do the site survey with a passive mode or an active mode. And to be able to answer these or to specify which is the correct one, it's basically we need to understand what is passive and what is active. Okay, so the passive one, from its name, it's basically the site survey is done with a listen-only mode. So we have a tool, like we said, the wireless adapter itself, it does not connect to any access point. It does not do any authentication. It does not connect to the Wi-Fi. It does not connect to the SSID. It passively only listens to the packets over the air and records the information, the RSSI value, the SNR value, etc. It does not connect to the access point. However, the active mode, it actually connects to the access points, does the authentication, connects to the SSID, do roaming between the access points, and does everything like a normal client does. It does not only listen like the passive mode. So from this piece of information, you can actually know which one is going to take more time. The active mode definitely going to take more time because the wireless adapter is going to connect to the access point. It's going to authenticate. And when we roam around, it's going to let the wireless adapter have to roam around and re-authenticate and do whatever the normal client does. So definitely, if we're going to do it as quickly as possible, as the question says, definitely I'm going to suggest to do a passive mode. Okay, so the answer is going to be passive mode with 2 wireless adapters. Next question. A customer has multiple WLCs running in N+1. So it could be 2 WLCs or 3 or 4 or more. So they are running in N+1 redundancy mode with APs load balance between the two. So they are balance the access points. Let's say that we have 100 or something. They are going to be like 50-50 or 25-25-25-25. So they are balanced between these WLCs. The customer performs the AP failover testing between the WLC and notices that some of the APs does not move back to their primary WLC after it recovers. So the customer basically tests the AP failover by technically, like, it could be like he shut down the WLC, the primary one, or there is a command that he could done it on the primary controller to force the APs to go to the other controllers. So they went to the other controllers, but they do not, after the primary controller goes back, it does not, the access points, they do not automatically go back to the WLC after it recovers. What are 2 points that must be addressed in this design? The options that we have is AP fallback is not enabled. AP does not have the primary WLC information configured correctly. DHCP option 43. APs do not have their secondary WLC information configured, and APs failover priorities are set to low. So when I think about APs not going back to the primary controller, I think definitely of 2 options. The first one, if we open the controller general tab, we have an option that says AP fallback, and we have 2 options for this one, is whether it's enabled or disabled. If this option is disabled, when an AP goes from one controller to another, if this option is disabled, it's not going to go back to the other one. Okay, it's going to stay on the secondary controller, but if it's enabled, it's going to definitely go back to the first one, to the primary controller. So we need this option definitely enabled if we want the APs to roll back to the primary controller. The second option is, I can think of, if we open the details for any AP, we have the primary controller name, address, and everything. And we have AP failover priority, okay? This basically set the priority that the access points fall back to the controller. So with either it's set to low, medium, high, or critical from low to high. This is going to be one of the options that you want to change if you want any access point to go to the other controller as fast as possible. So when I think about the options, it's going to be definitely A and E. AP fallback is not enabled in the controller, so we go back, like I said, and enable it on both controllers or on the primary basically, and the secondary and other controllers, since we have N+1. And the AP's failover priorities are set to low. We need to increase it to medium or to high or critical. Next question. How does the environment affect the wireless network when conducting a site survey in a multi-floor building? Okay, so here we're going to talk about multi-floor. The question is a multi-floor building. So every single one of these is actually correct. It's not wrong. An elevator shaft actually blocks an RF signal, and elevator shaft actually cause a signal scattering. However, we're talking about multi-floor building, so it definitely gonna be because of floor issue. So it's not elevator, it's not this one. It's gonna be probably the stock room supply causes noise floor. So because we're talking about a multi-floor building, it does not talk about a single floor, but all these options are actually correct. But with this question, with the multi-floor option, it's gonna be the noise floor. Next one. Refer to the exhibit. A company is designing a Cisco wireless solution that has two controllers named WLC1 and WLC2 and several APs. An AP named AP12 is a critical AP, okay? So AP12 is really important, and provisioned to be installed in a Highway 6, which is located just outside the office of a company director. So higher management. So this access point to 12 is really important, and must always connect to WLC1, which priority level must be incorporated in the design for AP12. So let's go to the exhibit that they say about it. Okay, so here we have the AP summary, and we have the controller or network summary, but we're most interested in the show AP summary. So we have example here AP12 and AP11, and we can see their information and the priority of it. By default, any access point is set to priority 1, which is the lowest priority. Okay, so if AP12 is actually very important, we're gonna need to increase the priority to the maximum. So let's see the options that we have in this questions is basically 1, 2, 3, or 4. So like I said, 1 by default is the lowest priority level. So if we need this AP to have the highest, it's gonna be option number D or 4, the highest option, the highest priority level. Okay. An IT administrator is trying to establish the criteria for a predictive coverage design. The environment is a mix of .11g data and voice. This is very, very important. We're talking about data and voice. Why voice? Because it has really critical set of criteria that we need to adhere. So we're talking about which minimum coverage with SNR25 aligns with Cisco best practices. So forget about Cisco best practices. Let's say that we do not know what is Cisco best practices, but since we're talking about voice, of course, I'm gonna eliminate anything that has a very low or very bad RSSI. So definitely I'm gonna remove or eliminate RSSI of -80. Basically, this is very bad RSSI to connect to. We also have the -75, okay, these, and also -72. These are not really bad, but since we're talking about voice, we really have to be connected at -67 or better for very good and clear voice. And we need to about 15 to 20% intercell overlaps, meaning that access points to each other need to be overlapping from 15 to 20%. So the answer is A, RSSI of -67. A customer currently is migrating the old wireless infrastructure to a new iOS based solution and wants a mobility group configured between a Cisco iOS WLC and an iOS WLC. So we have two controllers, which is iOS WLC and an iOS WLC. During this migration phase from iOS to iOS, the layer 3 roaming between the WLCs must be seamless. Okay, the roaming between the multiple controllers must be seamless, which actually meets this requirement. So let's show you here basically what's exactly happening. So this is what the customer is having. We have a newer deployment, a Cisco Catalyst 9800, okay, a new one, and then we have the old one, an AeroS controller running an older version. So, and between these deployments or between these two sites, we need to have a seamless roaming, okay? When we have roaming between different models, a newer one and an older one. It called basically IRCM, which is inter-release controller mobility between the two of them. So let's see what Cisco have to say about when we need to have roaming between in such scenario. So in this migration design phase, when defining a common SSID, that means a same SSID for roaming, it is recommended to have a different VLAN ID. Okay, recommended to have a different VLAN ID, but we need to have a common SSID, the same SSID, and subnet on the Catalyst 9800 and AROS with WLC. All the roaming between the 9800 and AROS controller is actually layer 3 roaming. This means that no matter what the VLAN is, the SSID is mapped to, on each WLC, the client will always be anchored to the first controller it joins. Okay, so we do not care about the VLAN. It could be different, but we need the same SSID. Okay, keep this in mind. In this scenario that we have different controllers, we're gonna need same SSID so they can roam seamlessly, and it does not matter the VLAN. It could be different, it could be, but it is recommended to have a different VLAN ID. Okay, so keep this in mind, same SSID and different VLAN ID. So I'm going to eliminate anything that says different SSID, and we're going to have the same SSID, but like we said, I'm going to also choose different VLAN ID. Okay? Okay, our last question. An engineer must design a predictive site survey. The wireless network must be location ready. Each floor is quite small and has only few offices. Which approach must be considered? Do we put one access point on each floor, 2, 3, or 4? So, like we said before about the site survey, this one is a predictive, so we do not actually go on site and do a design. We basically can have the map, put in a software application, and we put the access points that we need and just test the coverage that we have. But since the question says that we need the site to be location ready, first of all, what is location ready? We need to be able to tell where is each client is at. So if we have any wireless device here, we're going to need at least 3 access points in order to tell exactly the location of where that client is. Like this one exactly. We have a mobile device here and 3 access points, a minimum of telling exactly each access point is going to tell us the RSSI value, and based on that RSSI value, we're gonna know exactly where the mobile device is. So if we have 1 or more access point, it's not going to be visible at all, because it can be, let's say that here it's the mobile device is at, let's say, 10 meters away from the access point. In any directions, if we use only 1 access point, it's not going to be able to tell exactly where is it. Okay, maybe it can tell us that the client is 10 meters away, but in which direction, we do not know. But if we have 3 access points, we actually know, because each access point is going to tell us the value of the RSSI, and then we can know where the mobile device is, or where the client is. So in this one, I would say 3 or 4, but since we have each floor, the question says each floor is quite small, I do not believe that we need 4 access points. Of course, if we add actually 4 access points or more, it's going to be more accurate for location. But since it's a very small office, I think 3 access point is more than enough. So definitely not 1, not 2. The minimum is 3. We can put 4. It's not a wrong answer. But like I said, for this question, since it says it's a small office, we only use 3. Is more than enough. So the answer is C. So thank you all for attending today's class at 591 Lab. We hope you find the material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with the 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. And have a great day.